Here, Susie. We are at the airport now.
Wow, Grandpa, it's huge! And there are a lot of people too here.
Of course, Susie. People from all over the world landed here before they come into our country.
Grandpa, look! An airplane is taking off! Whoa, it's moving very fast.
Well, its engine is very powerful. Of course, it will move at that speed.
I wonder what its actual speed is when it is above us.
I wonder too. Alright guys, let's help Grandpa and Susie calculate the actual speed of the plane when it is above them. Based on this picture, an airplane is flying overhead at a constant elevation of 8,000 feet. Susie and her grandfather are viewing the plane from a position of 6,000 feet from the base of a lamppost. The airplane is flying horizontally away from them. If the plane is flying at the rate of 800 feet per second, let's find the rate of a distance between them and the plane. Let's see the first step. As shown, R signifies the distance between them and the position on the ground directly below the airplane. The variable Q signifies between them and the plane. Both Q and R are function of time. Since an object's height above the ground is measured as the shortest distance between the object and the ground, the line segment of length 6,000 feet is perpendicular to the line segment of length r feet, creating a right triangle. Now let's move to step 2. So we were told at the beginning that the plane speed is 800 feet per second. Therefore, the RDT is equal to 800 feet per second. Now we were asked to find the rate of change in the distance between them and the plane. We need to find dq dt when r is equal to 8,000 feet. Okay, let's list down all the information given. Now step 3. From the information given, we can use the Pythagorean theorem to write an equation relating r and q. Next, step 4. Let's differentiate this equation with respect to time. Let's continue from where we left. This time, let's find the rate at which the distance between them and the plane. Let's list the information that we have found earlier. Now we are going to find the value for Q, so that we can find the value for dq dt. Let's solve the first equation to find the value of Q. Let's use the Pythagorean theorem from step 3. First, write the formula and then let's fill in the formula with the exact value. Since r is equal to 6,000, let's put 6,000 inside the formula and then let's solve this equation. We must add 6,000 square with 8,000 square equal to Q square. After that, we will get 100 million equal to Q square. Then you must square root 100 million to get the whole value of Q. Then we will get 10,000 for Q. Since now we have the value of Q, let's solve the full equation. Let's use the equation from step 4 and then fill in the exact value in the equation. Now, we need to multiply 6,000 with 800 equal to 10,000 dq dt. After we multiply the value, we must divide it by 10,000 to get the value for dq dt, which is 480 feet per second. So we have figured out that 480 feet is the distance between them and the plane. Now, let's say that we want to change the situation. Imagine that we want to find the speed of the plane if the distance between Susie and her grandfather with the plane is increasing at the rate of 600 feet per second. Let's calculate it. Let's use the same value for R and H. So we will get 10,000 SQ and dq dt is equal to 600 feet per second. Let's use the same equation. So after we fill the equation, we will get the value for dr dt, which is 1000 feet per second.